Hello, welcome to Ludic Science. Today I will show you how to build a dummy load. Sometimes you need a load that draws a specified amount of current. For example, to test power supplies or batteries. Of course, this is something that you can do with a simple power resistor. For example, this is a 12 ohm resistor, and if we connect the resistor to the power supply at 6 volts, it will draw half an amp because of Ohm's law. There it is. However, if we need a different value of current, we will need to change the resistor. And also, if we need to change the voltage and maintain the same current, it cannot be done with a resistor. Because if we raise the voltage, for example, to 10 volts, because of Ohm's law, the current will also go up. And conversely, if we use less voltage, the current goes down. Using a dummy load, you can solve these problems because you can select the current that this circuit will draw just by varying the potentiometer. And the circuit will always draw that current independently of the voltage setting of the power supply or of your battery. Next time you need a PCB for your electronics project, consider using the professional services of JLC PCB. JLC PCB is the world leader in PCB fabrication. You can order online. You just need to register, upload your Gerber file, and wait a few days for your PCBs at an unbeatable price. The circuit is based on a LM358 operational amplifier, and what this does is to compare the voltages at pins 2 and 3. If the voltage at pin 3 is higher than at pin 2, then we will have a voltage at pin 1 and the MOSFET turns on. Then the current can flow through the MOSFET and through this resistor. On the other hand, if the voltage at pin 2 is higher than at pin 3, no voltage will flow here and the MOSFET turns off. Voltage at pin 3 is controlled by the potentiometer, and the voltage at pin 2 depends on the current that passes through this resistor. It is a 1 ohm resistor, so 5 amps of current will generate 5 volts at pin 2. Therefore, depending on the voltage that we apply at pin 3, the MOSFET will turn on and off when the current drawn by the circuit makes this voltage to reach the same value at pin 3. In this way, we can control the amount of current that the circuit draws just by varying the potentiometer. Here we are using a 7805 voltage regulator to fit the operational amplifier. Let's see how it works. The circuit is connected to the power supply. Let me turn it on. We are applying 7 volts and it is drawing 537 milliamps. And we can vary that current turning the potentiometer. More current, less current, with the same applied voltage. Let's fix the current at around 500 milliamps. And we can vary the voltage of the power supply, and the current stays at the same value. There is a limit, however, to the minimum voltage that we can use, which is 5 volts. If we apply less than 5 volts, then the current no longer can be maintained. and the reason is that we need at least 5 volts to feed the voltage regulator. If we need to use less than 5 volts, then we need a separate power supply for the regulator. For example, a battery. This is the input of the voltage regulator, so if you want to use less than 5 volts, you will eliminate this connection and you will put a battery, a 9 volt battery with the positive here and the negative here. Okay, now I connected the voltage regulator to a 9 volt battery and let's see again. At 7 volts it is drawing 570 milliamps. We can use more voltage. The current is the same, and now we can go down to less than 5 volts and the current is maintained. Okay, there you have it, a dummy load for your projects where you require a constant current. Thanks for your visit, I hope you liked the video and see you in the next one.